it turns out that these images don't just differ in the age, they also differ in pose, expression, illumination. So you have to account for that as well. It's not that they're all frontal faces and neutral expression and under controlled lighting. So here is one example, same person from age 2 to age 43. Now, the people who provided the database also manually marked the feature points. Okay, so if you want to do this AAM model fitting and so on, that becomes fairly easy with this. So this database, there's another database if you're interested called Morph that has larger number of subjects, but it doesn't have as many images per subject. So in that sense, it's sparser, but this is a good database available to build the aging model. So I don't want to go into the details of the aging model. If you're interested, I can send you one of our papers which appeared in the Gesture conference in September. But again, we use a Markov-Vogel model and input feature points. In this case, the feature points were already provided. Do some model fitting and then generate the frontal pose and then do the matching. So just to skip a lot of details which may take more time to explain. But the advantage of having the model is that now if you give me an input face at age 2, I can generate images at other possible ages. So if you want to match the same person at age 2 with image of the same person at age 5, I would first do this model and transform the 2-year age into a 5-year age before I do the matching. And you can do both backwards and forwards. So I mean, you can make a age 15 image and see how it would look at age 10. And this has many applications. Missing children, for example. I mean, that's if you want to use automatic system to verify the identity. If these two facial images are of the same person, which is different 5 years apart, then this model kind of thing is useful. So again, this is just showing the accuracy, rank 1 recognition accuracy, or this is the CMC curve, cumulative matching characteristics curve. Horizontal axis is the rank, vertical axis is the accuracy. So the green curve shows what happens if I matched using the Cognitech or commercial face matcher an image which differed by 10 years. So these experiments were performed over different age group combinations. We didn't match a 0-year age photo to 69. It's not going to work. So we sort of maintained a 5-year interval, 10-year interval, 15-year interval, and obviously if you do 5-year interval, performance will be better than if it is 10-year interval. And so I think this is averaged over multiple age groups and multiple subjects. And so the performance, rank 1 performance improved from about 26% to 37%. So, some improvement is better than nothing. But this is again, as I said, it's like a research topic where some of you may be interested in working. And this just shows some examples where the system worked and system didn't work. For the first 4 examples which are shown in green, after the age modeling, they were correctly identified at rank 1, whereas without age modeling they were not. And the last 2, the age modeling didn't improve the results. So on the leftmost column is the probe, on the rightmost column is the gallery. So that's in the first row, the probe is at age 18 and the gallery is at age 0. And by doing the modeling, it worked. Of course, it all depends on the size of the database and what is in the gallery. If you keep on increasing the size of the gallery, the performance will keep dropping. So that's what, all the performance results are based on a particular database. If you change the database, you may not get the same performance improvement. So then while we were doing this work, one of our friends visited the Museum of Modern Art in New York. And there was a book there called The Brown Sisters. So it turns out these are 4 sisters, okay, same last name Brown. And one of the sisters married a professional photographer. And he started collecting the photographs of all the 4 sisters every year when they had a family reunion or get together. And then they published a book, okay. So you have images of the same 4 women from 1975 to 2007, okay, taken every year. So that's a good database to verify whether the model which we trained on FGNet would also work on this database. So this just shows these images of 4 sisters in 1975 to 2007. And again, the rank 1 accuracy improved from 15.6% to 28%. That is, we took the trained model on the FGNet and applied it to this. And we did the same thing, trained it on FGNet and applied it to Morph, and the performance did improve. So the next thing is, again, this is a project in progress. We started. And in this project, we received a lot of cooperation from the Michigan Forensic Lab. So they have given us 500,000 face images, 500,000 face images, mug shots. That is when I don't know if everybody knows what a mug shot is, but when you are arrested for some crime, or the police, takes your fingerprint and then they make you stand holding something in front of you. You've seen in the movies or the TV shows, and then take a photograph. That's called a mug shot. Okay, I don't know where the mug means. I think you're not, it's not a happy occasion. You're muggy, whatever. And so their database is probably about 2 million face images, and they were very kind to us and said, well, you're doing some interesting work, we can give you 500,000 images. So we have these images, and in this database, many individuals have multiple images. Now, why would we have the same person many times in the database? Well, the guy got arrested many times, and every time you get arrested, you get an image. So that's a good database to study both the aging as well as the facial marks. So, all of us have some facial marks. Some of the marks are just temporary, but there are some marks which are permanent, okay, which don't change over time. I mean, you may have a slight cut, and so that's a mark today, but then after a few months it goes away. But there are some marks which are permanent. I mean, a permanent scar or a mole or something like that. And this is something which the forensic scientists, when they testify in a court, that yeah, I absolutely say that this is the guy, they use such information because quite often when they compare 2 images, one of them may be person leaving the bank after a robbery, so you only have a profile view, but the presence of a mark can confirm that. So that's what we were trying to do. And here we are showing some marks called moles and scars and freckles. And so if you want to do this, first we have to have a system for automatically extracting these things. So this is what we are currently working on. Automatic face mark detection. And again, this is where AAM model comes in useful. That is, first because in order to detect the marks, we want to get rid of the prominent features like eyes and nose and the mouth, okay, because those are not important for mark detection. And so that's what it means is subtract primary feature region from the face. And then you have to use some morphological image processing operators to find the face marks. So here I'm showing you 2 suspects here, okay? 2 different images of the 2 suspects. Okay, so they're both in the database, right? And when we do matching using Cognitech, they don't match at rank 1. Okay? But then when we also extract some facial marks, and match the facial mask